So we want to answer the question of how can we predict solubility? How can we predict solubility? So let's say we mix these two solutions together, strontium nitrate and potassium chromate. And they form this dissolution reaction, right? Where strontium chromate is a solid, and there's this equilibrium between the precipitation of strontium chromate solid and its dissociated ions. So how can we predict the solubility of strontium chromate? How can we know at any moment where it is relative to equilibrium is essentially what we're asking. So it turns out in the same way that we can make predictions about a reaction and what direction it will shift to be at equilibrium, it's the same thing with predicting solubility. We can compare Q, right, which is we have this expression for Q, right, that corresponds to the product of the concentration of our products over that of reactants. In the case for dissolution reactions, it's just our products. And we can measure Q at any moment, whereas our KSP, our solubility product constant, is only at equilibrium concentration. So we can compare these two to make predictions about the solubility of strontium chromate. So remember where we compared Q and K, right? If Q is greater than K, the reaction shifts to the left. The reaction shifts to the left because usually, right, that means we have a higher concentration of our products. So in the case of solubility, this means that a precipitate will form. It will form decreasing the ion concentrations until equilibrium is reached. Now when Q is less than K, it shifts in the opposite direction where we don't have a precipitate and we actually have dissociation. The solution is said to be unsaturated, meaning you can add more strontium chromate, you can add more solid, and it will continue to dissolve and dissociate into its ions. Now when Q is equal to K, the solution is saturated. It's just at the point of precipitation. So if we add any additional solid, it will precipitate out. We basically have this equilibrium where the rate of dissolution going to products is equal to the rate of precipitation going towards our reactant. So the rules here are the exact same when we're comparing Q and K to make predictions about equilibrium. It's the same idea for predicting solubility. It's just within a different context because we're talking about a specific reaction class, which is a reaction class that the class is dissolution reactions. So the Q to K comparison is the exact same that we learned in equilibrium, just within a different context. Just within a different context. So in many ways, this should have felt like a little review.